Hello everyone, welcome to the world of binary stars. Now, as you know from the name itself, when we talk about two stars which are gravitationally bound to each other, like the planets are bound to the sun, in our solar system, then we call them as a binary star system. Okay? It is essential that we should understand the difference between a pair of stars which appear close by in the sky and a pair of stars which are bound gravitationally. More of this will come in the subsequent videos, okay? But whatever happens, you should have this idea very clear in your mind, okay? So here you have an image. This is actually an image. This is not an animation, so it might appear like a very pixelated image, okay, but this is what real astronomical images are, and this is not a movie taken at one go. This is a set of images taken over a long period of time, and hence it might appear that the central star is wobbling a little bit. It's simply because of the fact that the images have been taken after long duration, different nights of observation. And here you can see that the weak star is kind of moving around this central object. Okay? This is not actually a central object, they are both equally important. It is the center of mass around which both the stars will move around. So that also causes the wobbling, the apparent wobble of the central object. Binary stars are extremely important because by observing them and from their properties over the last few hundreds of years, we have been able to discern many fundamental physics that is happening in the stars from the observation of the binary systems. And of course, if you go through the whole series of lectures, then you will understand what we are talking about. So, the discovery of white dwarfs was actually happened in the binary star system, first time. Then the whole idea of astrometric techniques, that also was developed once we understood the binary star system and started observing their motion in the sky. And of course, very, very important is the mass luminosity relation. And of course, to understand, to appreciate mass luminosity relation, you should understand the HR diagram and the whole sequence of evolution of stars and all the different classification of stars. And of course, if you look at the stellar formation theory and also the observation of the stars in the sky, you will realize that more than 85% of all the stars that we see are actually belonging to a multiple star system. What we mean by multiple star system? The simplest of the multiple star system is a binary system where the two stars are going around each other about their common center of mass. Then it doesn't really prevent you from adding multiple stars, additional stars into this system. So there are systems with 3 stars, there are systems with 4, 6 stars, and then slowly you come to the concept of clusters, tight open clusters like trapezium, and then you have the open clusters and the globular clusters. Okay, these are all gravitationally bound systems. So if you look in nature, if you look at the universe, it doesn't really create boxes of classifications that we normally use in our scientific endeavor. But we understand our concepts improve when we classify the phenomena or the objects that we see, and then we realize that okay, we can jump from one box to another box, one classification to another classification, and realize there are commonalities between the classification. Now 5% of the binary systems have more than 2 components. So again, you should realize that although a huge number has got to do with existing in binary system, only few actually exist in a system that has more than 2 systems. So this is a very, very intriguing problem that you should think about and consider the conservation of angular momentum when you are thinking about it. Okay? So we have the ternary system, quaternary system, 6-star system, and so on. We will see more of them in later. Okay, now let's get to the little bit of historical understanding how we have reached today in our understanding of the binary system. So, we should start from a point where Galileo uses his telescope and looks at the astronomical objects around and starts making claims which creates a complete furor in the whole system of our civilization actually. In 1617, this gentleman Benedetto Castelli, he actually asked Galileo to observe Mizar. Now, Mizar is a very, very interesting system. In fact, I mean, if you develop the timeline of Mizar, how we have understood that itself will provide a different series of lectures. It can, just understanding of Mizar required whole gamut of concepts that needed to be developed before we understand today that Mizar and Alcor form a 6-star system, and this was finally established in the year 2009. So, it has taken about 400 years for us to understand that when Galileo was looking at Mizar, they could visually identify 3 independent star systems, Mizar 1 and Mizar 2 and Alcor. Now, you should remember that, that these visibilities depend on 2 main factors. One is the flux that you are receiving from the star, and second is the closeness, how close they are. If they are too close, then they cannot be resolved. Okay? So, these are the 2 properties that determine whether we can distinguish 2 objects, 2 stars which are close together or not. And hence, because of the development of the telescope, Galileo started looking at these objects using the telescope. Then, in 1650, Gian Battista Riccioli, another very, very important person, he published that Mizar is a double star system. Understand that Galileo had actually done the observation decades before, but the way science progresses is that it has to have independent verification, and then after multiple observations, or in other branches of science you talk about experiments, in astronomy you talk about observations. Okay? So, after multiple independent verifications, only you can claim a certain aspect to be a fact of life. So, it took few decades for Riccioli to establish and publish that okay, Mizar is a double star system. Although today we know that Mizar and Alcor together form a 6-star system. Okay. Then in your school textbook, you must have come across the name of Huygens in the domain of optics, physical optics, the whole concept of the wave theory. But that was the era when astronomers and scientists and they were not classified into specializations. So, Huygens, Bessel, they were all excellent astronomers, and in their quest to develop the mathematical theory, they delved into all branches of science, of physics and mathematics, and they kept, they have lasting impressions on the knowledge that we have. So, Huygens confirmed around the same decade that we have the theta 1 Orionis system has a triple star system, which was already reported by Galileo sometime around 1617, 1618, 1620, around that time. So, Galileo had actually seen these stars, okay? But as I said, Huygens improved the observational techniques and he established that this is it. Then, as our observational techniques improved, various observers started reporting binary star systems, okay? And this became an established concept that, okay, stars exist in binary systems. Then we have to move about 100 years, okay, after a few decades after Galileo's first observation, when slowly people started developing observational techniques and verified that, okay, stars exist in binary systems. Let's go 100 years. Why was this gap needed? The reason is we developed methods of statistics. What we use normally today, that whenever you do any experiment or observation, we always talk about whether an observation is correct or not depending on the statistics. That determines whether we have observed something or not. When Higgs boson was observed, the declaration was made when they had the signal to noise ratio at a level of 7 sigma. So, it was 100 years we had enough data to develop the statistics. Okay? And then John Mitchell, he started the theoretical and statistical formalism of establishing a particular observation, whether a particular observation is statistically significant or not. So, this marks a very, very important step in the venture of science. Then we come to the same century, about a decade and a half later, we come to Christian Mayer, who then starts publishing the catalogs. Okay, so mind you, before this, people were observing, recording the data in their personal communications and letters, etc. But there was no comprehensive catalog. So, the idea of cataloging the observations started with Christian Mayer, and he actually gave the name of 80 such double star systems. And then comes the extremely important step by William Herschel. Okay? William Herschel was a great observer. Not only did he develop the observation science, observational aspect of astronomy, at the same time it was very crucial that he demonstrated theoretically that using Newton's laws you can actually now confirm whether a binary star system is gravitationally bound or not. This is a very, very crucial step, because earlier the only thing that we understood was that two objects appeared close by. Now you could distinguish between optical doubles and a binary stellar system. And this was kind of a triumph of Newtonian mechanics, that when it comes to heavenly bodies, we can now make a prediction as to whether a particular system is bound system or an unbound system. Okay? By the way, I should mention before I go to the next slide that Mizar and Alcor are also observed in many civilizations historically, including the Indian astronomical system, where Mizar and Alcor are termed as Vasishtha and Arundhati. What does Herschel's demonstration foretell? It tells you that you may be able to discover a binary star system where only one star is observed, but you look at its property, and from the properties and using Newtonian mechanics, you can infer that there is another star which you are unable to resolve, or for some reason it is not visible to you. You are unable to get a picture of the second star, and this is the very, very fundamental step when it comes to our scientific understanding of the system. Okay. Then we come down about, more than 100 years, the middle of the 19th century. There people, we have more than 150 years of observations, data recorded after William Herschel. So now what we do is that we have come to the great man Bessel, and he writes a letter to Humboldt. By the way, you should read about Humboldt. This person was a very, very extraordinary person. He went and discovered the jungles of Brazil and everything, and he was an astronomer as well. In those days, a traveler needed to be a very good astronomer because you guided yourself in the seas by looking at the star sky, star chart. So Humboldt was a traveler. He discovered the South Americas, and he was a great astronomer. He knew the chart, the sky chart very well, otherwise he wouldn't be able to guide himself. And Bessel was a great observer, an excellent astronomer and a mathematician. I mean, if you continue with physics or engineering, you will definitely come with Bessel's differential equation and his Bessel's functions. Okay. So, what Bessel writes to Humboldt is a big jump in our understanding and the way we approach problems in astronomy, and not just astronomy, in general science. So, what Bessel claims here is that the stars Procyon and Sirius, they are double star systems. From the observations that he sees, he is unable to resolve the binary companion of these stars, but from the astrometric observation, from the astrometric techniques that he has developed, he claims that these stars have to be a binary star system even if we cannot see them, because they have to obey the laws of physics. So, here we see that the whole branch of science is actually in that period taking a step forward, where you are using the theory to predict an observation that has not been done. So far, before this, everything that you did was you make the observation and then develop an empirical understanding and then move towards a theoretical understanding. This is a very, very important step forward. And after this, we will just quickly go through the concept of optical doubles. Okay? And you should understand that these two stars which are close together, they are not necessarily gravitationally bound. Okay? So, M40 is a system which is an optical double, but it is not gravitationally bound. So, Herschel gave the theory, I mean not gave the theory, but he actually worked on Newtonian mechanics, and he established the difference between optical doubles and the binary star system. Okay. Similarly, similar to optical doubles, you also have optical triples, but of course that idea can be extended. Okay. I mean, you can, if you go to a cluster, then you have lots of stars close together where they are loosely gravitationally bound, but here optical doubles and optical triples are not at all bound. Before we end this video, let's go through the whole list of the different types of binary stars. Okay? This we should be aware of. First, the type that is not a binary star, which is the optical double. Then we have the visual binaries, where you can see two stars going around each other. Okay? Then you have astrometric binaries, where you see only a single star, but from the observed path that it takes in the sky, you infer that there has to be a binary companion, and this class of binaries is known as the astrometric binaries. Then we have spectrum binaries, where you look at the spectrum of the star and you realize that this particular set of lines can exist only in different objects, because they depend on the different temperatures of the two objects. No one object can have the physical condition corresponding to the different temperatures which can give rise to the given set of lines. So, although you are resolving the object as one object, the set of lines that you see from the spectroscopy, you realize that they have to be spectrum binary, the binary system. Then you have spectroscopic binary systems, where you see the line moving, okay, due to the Doppler shift in the of the frequency or the wavelength, whatever you're looking at. And this, when it comes to spectroscopic binaries, you may be able to resolve two objects and measure the velocity of both the objects, or it can be that you measure the velocity of only one object and infer that it is a binary system. And last, but definitely not the least, is your eclipsing binary. where you are not looking at the spectrum, but at the total light from the system, and this light undergoes a dip. And you know that one object has come in front of the other and is occulting the other object. So these are the classes of binary stars. Okay. Now, before I end, another way of classification is very important that you should understand is the physical classification. In the previous slide, we saw the observational features. Here we are classifying the binary stars as physical classification, where you have whether the two binary star systems are close or not, because it impacts their evolution. So we can have a detached star system, we can have a semi-detached star system, or we can have a contact star system. Okay. In a detached star system, the two stars, their gravitational field, they are not interacting. I mean, you have a inner Lagrangian point, and the star is not filling the lobe which is belonging to itself, which is known as the Roche lobe. If a star is big enough to fill the Roche lobe, then we call a semi-detached binary, because then what happens, the surface of the star is kind of extending into the gravitational field of the other star. When both the stars fill their Roche lobe, then it is known as a contact binary. Okay. So detached binaries, there is no physical contact. Semi-detached binaries, when one star is big enough and starts getting influenced by the gravitation of the other star system, and the closed binaries, the contact binaries, here both have filled their Roche lobe, and you can have a mass transfer from one surface of the one star to the surface of the other star. Okay. So this is where we end this present video.